Okay, good morning, guys. Okay, so up to non-equi-join we discussed in the last session, right? And now we will go for the next join, exciting cross-join. Okay, right. So basically cross-join, when we want to and how it will work, cross-join means, can you remember we discussed in the introduction part of joins, I was given one rule is there, okay? Yeah, so we discussed this rule, the rule of joins. So in this rule, what we said, a row in a table is comparing with the all rows of another table. So this rule, how it was defined by people in joins, that means joins, how it was working and how this rule was defined by some people, that means the scientist, whatever who released this SQL, the Mr. E.F. Cod. So how he was designed this rule means it's depending on your cross join. So exactly the cross join is going to be work like this. Each row in a table is comparing with each row of another table. So the definition and rule also taken from cross join. Okay. So, and this is only one join, guys, here. It will be joining the tables, okay, without having any condition. And previously, if you want to see all the joins are, okay, if you whatever we discussed as of now and whatever we left, the two more, whatever it is, all joins will be working on based on join condition level. Okay. But this is only one and only one join, which was not using any kind of a condition. So without a condition, just the table is going to be joins together. And how it was joins together means each row to row joining. Okay, let me see. So right down below, joining tables, without any condition. Joining tables without any condition. Okay, but how it was joined means, okay, right now, each row in a table is, each row in a table is joins with each row of another table, okay. So for example, a table is having m number of rows, okay, m number of rows, and another table, okay, another table is having, okay, is having n number of rows, n number of rows, okay, rows, then then the result is, okay, so m cross n. Okay, so then the result is m cross n rows. Okay, so this is what it was happen, guys. So how it was working here internally means every row of a table is going to be joins with every row of another table, and finally this m cross n will be returns as your result. And suppose here m is equals to, for example, 3 rows, and suppose n is equals to, you have a 4 rows, then 3 into 4, how much? Yes, it was going to be, okay, the returns, okay, is equals to 12 times, or 12 rows will be created now. Okay, so that is what now cross join here. Let me see one example on this cross join. So come back to your database. So when we have table, we designed in the previously what is now student table. So it was having some 4 rows. And let me come back and see the second table is what now? Course. So in my student table, we have 4 rows here. Okay. And in my course table, we have here 3 rows. Suppose on these 2 tables, if I want to apply my cross join, okay. So then what it was happen, you can see. Okay. So select a star from student, comma, and course. That's it. And I'm not using any condition here. And even though if you write a condition, the condition maybe it is called a equijoin. Okay, if you write any condition, otherwise you can write any condition, it's called as a non-equijoin. Suppose, let you see, if I applied here, suppose s dot cid is equals to c dot cid. If I given like this is which join? Equijoin. It's called equijoin. Suppose if I want to give it, so suppose greater than c dot cid, this is which join? Non-equijoin. So either condition, if you give any condition, based on that condition, either it will become to equi or else non-equi. But I can't say it is a cross join. Yes or no? So that's why don't use any condition here, and you just leave it that and the student comma course. And how this was working internally means whatever I said, the each row to row, it will be joins together, and see how it was joining here. So your 10, 10, 10, 20, 10, 30, 10, 10. This is one record is happening. That's called a Oracle. Okay. Next is Java. The Java record is comparing with the 2010, 2020, 2030, and 2010. This is Java group. It was joining with the each row of another table. So next is .NET. So 4010, 4020, 4030, and 4010. So that means total how many rows guys here? 12 rows it was going to be happen. So this is non-ANSI format. Suppose do you want to write in ANSI format? So you just apply like this. So now my join key, what is my join key here? Cross join. So cross join, and I just give it here course and leave it that. So same output will be coming to us. Okay. So this is basic example, the how it was working your cross join we said. Okay. Now, but cross join, if you ask, sir, where I can use this cross join, because it was just for joining and comparing the row to row. Okay. But where I want to use this, in which cases I can use in real-time applications. Okay. Now, so now we can see this. So first write on this one. Okay, right. So let me see one more example, the cross join, how it was. Come back here to my database now. So first of all, I'm creating 2 tables now. So the first table is called as items 1 and serial number and later item name. Okay. So where I get 2 of some size and item price. Okay. It's the number of some size. This is one table we designed guys here. And after that, I'm going to inserting some records into this items 1 table. So serial number 1, The item name is called pizza, and this is 180 rupees. Okay. In the same pattern, I will go for my second item, for example, 2, and it was burger. Okay, some 85 rupees. So now this is one table I designed, guys, here. And the second table, I will go for this items number 2 table. And here also I will take serial number and item name. So varchar of some size and item price. And we are sending here number of some size here. So after that, you can see I'm going to insert few records into the second table, items number 2. Okay, and sending some values now. So serial number 101, the item name is Pepsi. Okay, it was 25 rupees. Okay, and the second item, I will take it here, 102. The item name is Coca-Cola. And this was, for example, 20 rupees. So finally, the 2 tables we designed, guys, here. Let me come back and see the tables. The first table is called as items number 1 and having some items into that, and items number 2 and having some here. So there are 2 items tables we have it here. The list 1, in this list, we have your pizza and burger. So their prices are there. And in items 2, we have some drinks here and their prices are there. Suppose from this 2 list, okay, from this 2 list items, any customer, they can come and order the combination of any 2 items from this 2 list of tables. Okay. So for example, one customer is came, he was ordered the pizza combination of Pepsi. Then whatever he was ordered, the combination, based on the combination, I need to generate my bill. The bill amount of customer, how much I need to generate here. So now in the second customer, he was coming out. So he was asking the combination of burger with combination what? Pepsi. So burger 85 rupees and Pepsi 25 rupees. Total bill amount 25, 110, 110. So like another customer is came, he was ordered burger with the combination of Pepsi. And one more customer, burger with the combination of Coca-Cola. So pizza with the combination of Pepsi, pizza with the combination of Coca-Cola. So like this, any combination the customer can order. And whatever he was selected, the 2 items from the 2 tables, and based on that, I need to generate my bill amount. Understand na? Let you see, I'm going to writing for this too. So select I1 is called as alias name. I1 dot I name, comma. Okay, I1 dot price, comma. I2 is alias name. I2 dot I name, comma. I2 dot what now? Price. Okay, comma. And next I will take it here. I1 dot price. Okay. I1 dot price. I1 dot price plus I2 dot price. Okay, that I will show as total amount. So total amount is what now? Alias name. Okay, then these are the things. And from the table items 1, and I'm using which join? Cross join. And second table items number 2. So I don't want to give any condition in this, and let you see as whatever you written in this query. So based on the query, it will be returns, but something is missing. What is that? So alias name, sir, we are not designed here. Okay. So I2 dot price and I1 dot price. Okay. Plus I2 dot price. Okay. And from I want to show as what I said, total amount. So total amount. Okay. And now, and from the first table. So what is my first table? Items 1 and I1 alias name. Compulsory we should give it here. Cross join. And items 2. What is that? I2. Okay. Aliases are we design. And after designing this aliases, and you can see this, the any combination the customer can order. So for example, one customer is ordered pizza with the combination of Pepsi. So pizza combination Pepsi, total bill amount how much? 205 rupees. Suppose one more customer is ordered Pizza with the combination of Coca-Cola and how much here? 200 rupees total amount. And burger, okay, 85 rupees and a Pepsi 25. So this combination 110. And burger with the combination of Coca-Cola, then it total bill amount is 105. Understand now? So like this, the bill generating. So nowadays you can see computerized bills are there. If you go to any shopping mall and any shop, so they after purchasing your all products, they will be generating one computerized bills. So how those computerized bills internally forming means that by the help of what now joins and especially cross join, they can use to generating their total amounts. Okay, so this is the advantage of what now cross join we can perform. Okay, this kind of operations generating bill operations with the cross join. Okay, right down below. Okay, right. This is cross join techniques. Okay, how we can use it. And the next one we can take siding here, natural join. So come to natural join. Okay, so how we want to and what purpose this natural join will be work. Okay, here observe. So natural join, simply we can say guys here, it was similar to equi join. It's similar to equi join. Okay. So why sir it was similar to equi join means this natural join is also working and retrieval your data from multiple tables based on an equal operator only. Okay. So it is also retrieving, okay, data from multiple tables, data from multiple tables. So based on an equal operator, based on an equal operator, okay, along with a common column, along with common column, okay. So along with a common column in tables. Okay, so now we can see, we said it is also retrieve your data from based on an equal as well as common column. Okay, but the question is, sir, when equi-join is also doing the same work, then why we need a natural join? And what is the differences between natural and equi? So maybe retrieving data is same, matching data only retrieval because of reason both are working on same operator and based on common column. Okay, so the final output will be same, it will become. Okay, when you use equi-join as well as natural join, because of both are working on equal operators. Then what is the differences here? Means here observe. Equi-join, can you come back? I will show you practically. Observe. These are the two tables or any table you can take, guys, here. So this is my two tables here, the student and course. Okay, right. So in these two tables, we have a common column. Okay, so based on that common column, first I'm writing my equi-join. So here I'm using star, select a star. Star means all columns. So star from the one of my table is student and comma, and I'm using what now? Course C, and we pass s.cid is equals to c.cid. So in this case, carefully observe the points. Here, equi-join, when I'm using the star, then equi-join what it will do, in your first table student, how many number of columns are there? That all columns are retrieval. And in your second table course, how many columns we have it here? That all columns are we are retrieval. Okay, so that means here star is nothing but what now here? All columns from the two tables, it was retrieval. But in these two tables, can you see one common column is there? Which one? CID. So it means it means what now? Your equi-join is going to be retrieval your data with the help of okay, along with what now? Duplicate columns. Okay, so equi-join, how it was retrieving your data means with the help of duplicate columns. That's the first thing. Okay, and the next one is what now? Whatever the condition was given by here, this condition was automatically prepared or user was given? User was given. That means explicitly the user has given this condition. I was written my own way, but it's not automatically. Yes or no? So explicitly user or programmer was written this equi-join condition. And based on that condition, okay, I'm using what now? Common column I'm using in these two tables, whatever it is common column. And which operator I'm using? Equal operator. So equal operator along with common column, I was written some condition, and based on that condition data we are pulling from the tables. Okay, so this is equi-join is going to happen. But the same thing when come to natural join, what's happened you can see. In the natural join also I'm using star. Star means all columns, and from my tables are student S, okay, and I'm using your natural keyword, okay, and natural join, and we're sending here what? Course C. But here observe, so I'm not writing any condition here, right? Yes or no? Yes, and I was used here star, but I'm not writing any condition. Okay, let's what happened you can see. Now tell me, in this two equi and natural join, do you identified any differences? What is the difference? The first thing is, here also I'm using star. Here also I'm using star. But equi-join is retrieving common column how many times? 2 times. That means the duplicate columns are repeated here. But when I'm using star, but natural join is a retrieval CID how many times? Only 1 time. That means duplicate columns are repeated or not repeated? Not repeated. That means avoided. So natural join advantage is what now? Whatever the duplicate columns are there and whatever the repetition of columns are there, those repeating columns are avoided. That's one thing, difference you identify. Second difference you can see guys here. Okay. Here I was written my query condition, but here I was written any condition? No, not at all. But still this output and this output same na? Yes or no? Output same na? Okay, so there I written my condition explicitly. Here I'm not writing any condition. But what it was happening in this both? Both are providing same result. So that means here what happened, you can see. In this natural join is also preparing the condition with the equal operator based on common column only. Okay, now. But sir, that condition who was prepared, who was given, who was created means your internally Oracle server is prepared that. That means user no need to give any condition when we want to use a natural join, because natural join conditions are automatically prepared by Oracle server. Okay. So how the Oracle server is preparing here? Based on common column and with which operator? Equal operator. That's why, can you see here also only matching data I was fetching now? Is there any unmatching data came? No. So only matching data came means which operator I'm using? Equal operator. So that's why natural join is also working based on equal operator. So your difference is what now? Equi-join is explicitly condition we are providing. For natural join, implicit. Implicit means system creation, automatically created. This is the difference here. Okay, write down below. Now, retrieving data from multiple tables based on an equal operator along with your common column name in a table. Okay, then what is your next one is, when we use natural join, when we use natural join, okay, there is no need, there is no need, okay, there is no need to write, okay, join condition. There is no need to write join condition by explicitly, by explicitly. Okay, here explicitly means user defined. Again, don't confuse. Okay, explicit means user defined. So there is no need to write join condition by explicitly because, okay, because reason is what now? Because internally Oracle server, okay, will prepared, Oracle server will prepare a join condition, prepare a join condition, prepare a join condition, okay, based on an equal operator, based on an equal operator, equal operator along with a common column name, along with a common column name, okay, by implicitly, implicitly. ओके, अरे यार मैं टेंशन में मैं सोचा कुछ हो गया है. Okay, so by implicitly. The next point, okay, natural join is used here, is used to avoid, okay, to avoid duplicate columns, to avoid duplicate columns from the result set, from the result set. Okay, right. And take one example on the natural join. Okay, right. The next one, self join. So this is most important join for your interviews. Okay. And somewhat complicated join also we called. Some little bit confusion was there, but try to understand. I will explain slowly. Okay. Right. So self join. So it's the most important. Okay. And carefully focus on this. Okay. Right. So basically, as of now, the before whatever the joins we discussed, guys, here, that all joins, once you want to recall, equi join, inner ANSI or inner non-ANSI, whatever it is, equi, inner, non-equi, outers, cross, and even though natural. So these all total 9 joins are, if you seek to compare here, so minimum I was used here 2 tables. Okay, and more than 2 tables also we can use that. How it is, I will explain to you. Okay, right. So as of now, what happened? The tables, whatever we done, the joins, whatever we perform, those joins we perform on 2 tables, and 2 table operational data we are retrieval. So like we discuss one table student, okay, with the course we are comparing. Next, EMP with the DEPT. Next, we compared EMP with the SAL grade. Next, we compared here test 1 table with the test number 2 table. Next, we compared here items 1. Okay, items 1 table into items number 2 table. So like this, these tables and these many tables I used in my joins. In this case, what it was happen, guys, here, one table, okay, one table data we are comparing with another table. So student comparing with the course, EMP comparing with the DEPT, EMP comparing with the SAL grade, test 1, test 2, items 1, items 2. So that means one table data we compared with another table data. Okay, now, so this is called as what now? Dependencies we called. Okay, this is called as what now? Dependencies we called. So now we can see, suppose student is going to be working and comparing with the course. That means student table is depends on course, and vice versa. Course is also depends on students. So like one table depends on another, and both tables we comparing to each other, and finally as per our condition the data will be retrieval from the 2 tables. So that was happened, and here comparison was done in between 2 objects. Object is nothing but table. Okay, in between 2 objects and in between 2 tables we done your comparisons. So of course, when we have 2 objects and comparison between 2 objects, it's very easy. Yes or no? For example, I have 2 candidates here. I want to compare these 2 people. What I want to compare? Height. He was tall, short, thick, thin. Yes or no? Black, white. Yes or no? So, like I can compare it. And comparison is also very easy. When we compare one object with another object, it's very easy because 2 physical objects are there. Those 2 physical objects I'm comparing here. That's not a big problem. That's not a big issue. I can compare it here. But here what it was saying? Self. Self means, are you comparing with others or else are you comparing by yourself? Yourself. That means I want to compare with myself only. I don't want to compare with the others. So comparing with others, easiness, very easiness, but comparing with ourselves, very difficult. Understand na? Yes. So yes, self, this is also the first point in the self join. What do you want to understand in this? Okay. Self join, the first of all should be remember, it was working on a single table. It's the first point, remember. So you can't use any multiple tables in this case. You can use only, okay. So single table data operations only we can perform. Okay, na? Right. This is first one. So that means working on single table. So that means how it was comparing means here. Now careful observe. Joining a table by what I want to say, by itself. Can I say? Yes or no? Joining a table by itself is called as what now? Self is called as what now? Self join. Okay, it's called as self join. Otherwise, even though you can define here, okay, one more condition is what now? Comparing. Okay, so comparing a table data by what I want to say, itself, okay, is also called as self join. Is also called as self join. So the two definitions we can go to give it here. So comparing a table data by itself is also called as a self joining, and self comparison also we can call. Okay, fine. So the definition we taken out and we confirmed here only one table can be used and work. Okay, that 2 points are confirmed. But now you have to think, okay, sir, in this self comparison, I want to use only single table. But a single table data, how it will be comparing by itself? So there is our logic is there. Okay, now tell me guys, suppose you want to compare with yourself, what do you want to do? Just think logically. Suppose you want to compare with yourself only, how are you comparing with yourself? What I need to support? Huh? Somebody saying what? Mirror. Yes, very good. So I need support of mirror. Yes or no? So when you want to compare your structure or whatever it is, suppose you just go and stand in front of mirror. So when you go stand in front of mirror, what it was happen? Your virtual image is reflected. Or else any Chandramukhi is come. Huh? No, na? So when you stand in front of mirror, what it was happen? Our physical structure is reflecting to us. So it means whatever mirror image is there, na? So can I say that mirror image is a physical image or virtual? It's a virtual. Yes or no? So when you stand in front of mirror, your physical structure will be absorbed by your mirror, and again it will be reflecting to you. And that mirror image, whatever it was there, that is called as what now? Virtual image of that physical object, whatever it was stand in front of mirror. Okay, now. So now once, that means one physical body is comparing with his virtual body. Yes or no? That virtual image also yours only, na? Not other, na? So I'm standing in front of mirror, then my virtual image is reflecting here. And now I want to compare the outside of the mirror is called a physical object. Whatever you are seeing in the mirror, that is called a virtual. So are you comparing your physical object with the virtual? And how many objects here? 2 objects. क्या दिमाग है यार तेरा? इस वन ऑब्जेक्ट यार, और कोई कोई स्टैंड है आपके पास में, गर्लफ्रेंड भी है यहाँ पर, तो इमेजिनेशन करके ओहो, कब देखो ऐसे ही सोचता रहता है. अरे यार one object यार, we are discussing about one object, not two objects. Huh? How many people standing? तो दो केस आ गई आपको. Huh? So only one object. So one object by itself comparing. Yes or no? Not other. So how, that means your point is what now? If I want to compare with myself, I want to create one virtual image. Yes or no? That's the point here. Whatever I'm saying that example. Okay. One virtual image I want to create. So when we preparing virtual image, okay, then with that I'm going to comparing. Okay. Same logic. Whatever the mirror logic is there. Okay. Same logic I want to implement in this self join. Understand now? I want to implement in this self join. And now we want to think. Okay, sir, here the mirror is there. With the help of mirror, I can create my virtual. But this is not a mirror. Na? This is not a human being. Na? It's just one concept. Yes or no? Topic. Now you can think how I want to create a virtual on a table. Do you have any concept we discussed like this in the previously? And I said to you that concept is very important in the future classes. Anybody remember? At the time, that concept, whenever I was explained to you, I said to you, this concept in the future, especially in joins and subqueries, it was using that concept. Tell me. Aliases. What is that? Aliases. Okay. So now here also, when you want to implement my self join mechanism, compulsory we should create a aliases. Without aliases, you can't implement this self join. Okay. Then what it was happen, you can see. So observe here. So write down. When we use self join, when we use self join on a table, we should create alias names. We should create alias names. Okay, on a table. Okay, on a table to implement self join, okay, mechanism. Okay, when we use self join, we should create, okay, we should create alias names on a table to implement a self join mechanism. Okay, but here what it was happen, you can see. Once you created virtual, that means the alias names, what it was happen means, here observe. So once we created, okay, alias names on a table, internally, okay, so Oracle is preparing, okay, virtual tables. Preparing what now? Virtual table, okay, on each alias name, okay, on each alias name. So internally Oracle is preparing virtual table on each alias name. So for example, here observe. Suppose, okay, for example, is a one person. Okay. So around him, there is some mirrors are there here. The mirror 1, and this is mirror number 2, and this is mirror number 3, and this is mirror number 4. So around him, how many mirrors? 4 mirrors. So when you stand, okay, in between mirrors or around it, that mirrors, what it was happen, guys? How many images will be created? 4 images. So that means this person image will be reflected into mirror 1. Okay, the same image is reflected into mirror 2. Okay, Same image is reflected into mirror number 3 and same image reflected into mirror number 4. So this is M1, this is M2, this is M3, and this is M4. So how many virtuals? 4 virtuals. On how many physical? 1 physical. So that means, is there any limitation? Do you have any limitation? No. So when you stand in front of how many mirrors, the thousands and lakhs, so you can go and stand it here, and that many virtuals are reflecting here. Yes or no? So there is no limitations here. We don't have any limitations. Okay. So same like this, when you created alias name, okay, on a table, what happened internally? Your Oracle is going to be preparing what now? Virtual tables. For example, suppose I'm going to create one table. So EMP is my table. On this EMP table, suppose I want to create some aliases like E1, comma, EMP E2, comma, EMP E3. So on the same table EMP, how many aliases I created? 3 aliases, E1, E2, E3. Then what it was happened, sir? Internally means on the name of E1, one virtual table created. On the name of E2, one virtual table created. On the name of E3, one virtual table created. So that means, how many alias names are you created on your table? On each name of alias, one virtual table, sir, preparing by your Oracle. Understand, na? Yes. So this is like this. You can create any number of aliases. There is no limitations. On one 10th class certificate, how many Xerox copies can I take? Do you have any limitation? No. On your original copy, you can go to Xerox center. Your lifelong you have to take a Xerox copies. There is no limit. Same like this. Table is my 10th class certificate. On that certificate, how we are creating Xerox copies, same as virtuals also. Okay, you can create any number of virtuals. So that point I'm giving now. Okay, so what is that? We can create any number of, okay, any number of alias names, okay, on a single table. On a single table, but each alias name, should be different. It's a very important point. Okay, should be different. So that means the duplicates are not allowed here. The point, understand? Duplicates are not allowed here. Suppose are you created now? See, don't write, observe. Suppose I was given EMP E1, EMP E2, and EMP E2. What's happened here? Your duplicate names I created. Yes or no? Where it is my duplicate names? Here. So E1 is okay, but when it come to E2, so that means the 2 aliases, whatever you created, those 2 alias names are same names I was given. But whenever you try to give like this, it will be not accepted. So you can create any number of alias copies, but every alias name should be different. So not a same. That's point is okay. That was very important. Okay, now right. So these are the information, guys, about your self join. And finally, the conclusion. What you can say here? The final conclusion point here. What I can say? Without alias names, what we can say? We cannot implement which mechanism? Self-join mechanism, or simply self-join. So this is very important, guys, here to remember this point. That's conclusion. Without aliases, you can't. Self cannot be implemented. Okay, right. So the next question. Okay, sir, the self-join, finally we understand that it was working on single table, and we should use a aliases. These are the major points by all the seeing this all points. Okay, the key points are what now? One table should be used and aliases compulsory. These are the key points, these two. Okay, right. But in which cases I want to use the self join? Because remaining equi join, inner join, outer join, these are what now? Are two tables are there. Whenever I want to retrieve the data from two tables, then I can use equi, inner, outer, whatever it is. But self, what I said, it was using only single table. So data retrieval from single table. But in which cases, when I can, in which kind of situations I want to use my self join? Okay. So there are two situations are there, guys. Here. Case one, right now. So self join can be used in two cases. Okay, wait. Okay, write down. It can be used in two cases. In two cases. Okay. The first case, the case number one, comparing a single column values, okay, by itself within the table, okay, table. This is my first case. I want to use my self. Comparing a single column values by itself within the table. Okay, this is one case I wanted a self. And the next point is case number two. The case number two, comparing two different columns values, two different columns values to each other within the table, to each other within the table, to each other within the table. So the both situations, guys, either single column comparison or else we can go for multiple columns comparisons. But whatever the single column and whatever the multiple columns, whatever you want to compare here, the comparisons will be happening only one single table only. That's why I said here what I said, within the table, not with other table. Within the table only, not with the other table. Understand now? So these are the two cases when it was come to you. Okay, immediately you have to use your self join mechanism. And in entire the joins topics, this is only one join which will be working on one table data operations. Okay, now so a single table data operations whenever you want to perform by using of joins techniques, and that was only self join. And remaining all joins are working on multiple tables except self. Clear na? Definitions clear na? So this is, and now later we will see, okay, the examples here. So how it was comparing single column and how it was multiple columns. Okay, so these practical examples I will show you tomorrow. What is the time here? 30. Tomorrow I will show you these two examples, and maximum we will be close tomorrow. Maximum we will try to close our joins. Okay, right, guys. So thank you so much.
స్ట్రింగ్ ఒకసారి చెప్పండి సార్. స్ట్రింగ్ చెప్పండి సార్. స్ట్రింగ్ అంటే మీకు స్ట్రింగ్ ఉంది. ఆ స్ట్రింగ్ లో మీకు అనుకున్న క్యారెక్టర్ ఏ పొజిషన్ లో ఉంటే ఆ పొజిషన్ ని నేను ఫైండ్ అవుట్ చేయాలి. సో ఏం చేశాను, ఈచ్ అంటే నాకు ఏ క్యారెక్టర్ పొజిషన్ ఐ వాంట్ టు ఫైండ్ ఈ క్యారెక్టర్. సో ఈ క్యారెక్టర్ నేను ఫైండ్ అవుట్ చేయాలి. ఓకే, అంటే ఇందులో ఈ స్ట్రింగ్ లో ఈ క్యారెక్టర్ అనేది హౌ మెనీ టైమ్స్, 2 టైమ్స్ ఉంది. ఒక ఈ అనేది పొజిషన్ నెంబర్ 2 లో ఉంటుంది. ఒక ఈ అనేది పొజిషన్ నెంబర్ 7 లో. సో నా ఇక్కడ ఏంటిది స్టార్టింగ్ పొజిషన్, మీకు డాక్యుమెంటేషన్ ఇచ్చుంటాను. ఒకసారి చూడు, ఇది స్టార్టింగ్ పొజిషన్ ఆఫ్ ది క్యారెక్టర్. అంటే ఏ క్యారెక్టర్ నుంచి నేను కౌంట్ చేస్తాను, అది కాల్డ్ 1 అంటే అంటే అక్కడి నుంచి నేను కౌంట్ చేస్తాను. అక్కడి నుంచి ఈ అనేది ఎన్నో ఈ కావాలి నీకు, సెకండ్ ఈ కావాలి. ఫస్ట్ ఎక్కడ డబ్ల్యూ నుంచి సెకండ్ ఈ పొజిషన్ అనేది కావాలి. సో అది పొజిషన్. సో డబ్ల్యూ అని చెప్పారు. ఇది ఎన్నో పొజిషన్, సెకండ్ ఈ పొజిషన్. సో అప్పుడు ఏం చేస్తుంది, ఇక్కడి నుంచి కౌంట్ చేస్తుంది. 1 2 3